Hey everyone, welcome back to Code in Motion. Today we're looking at LeetCode problem number 191, number of 1 bits. This is a really cool bit problem in LeetCode and helps you get started to understand binary representations of numbers. So given a positive integer n, write a function that returns the number of set bits, which is just 1 bits, in its binary representation. So if n is equal to 11, in binary this is written as 1011. And so we should output 3 because there are 3 ones. All right, so let's get started with the algorithm. I'm going to have a number of ones tracker on top, which is going to be our result. And we're looking at the number 29. How many ones does 29 have in its binary representation? The first step is actually to convert this 29 to its binary representation. And so 29 actually becomes 11101. Now, how could you do this with a pen and paper by yourself? What I always like to do is draw these lines over here and draw how it looks like in decimal form, right? So in base 10. In this case, we have 1, 2, 4, 8, 16, etc. And what you could do is where you have a 1, you would count that number. And so 11101 becomes 16 plus 8 plus 4 plus 1, which is 29. That's how you can verify if you have the right binary representation. Now, with that out of the way, let's actually process the least significant bit at a time. And so this is the bit on the right-hand side. I want to know if this number, or if this bit, is a 1 or a 0. If it's a 0, then I don't add it to my result. But if it's a 1, I need to keep track of that 1. And so how can we only get the last number? How do we know if it's a 0 or a 1? The trick over here is to AND this number with 1. And let's see how that looks. If you AND it with 1, look what happens to the other bits in this number. 1 and 0 is always 0. And so all the other bits besides the least significant bit becomes 0. And since we have a 1 over there in the least significant bit, 1 and 1 is 1, and 0 and 1 is 0. So essentially for the least significant bit, if we AND it by 1, we're always going to get that bit's value. And so let's see what that looks like in the result. We get 0, 0, 0, 1, right? And if we AND our number with 1 and the result is 1, we update our result. That means we found a 1 in the least significant bit. However, if it's 0, then we don't add a 1 to our result. And this is going to be the base algorithm that we use. So we update the result to 1, and now I need to get rid of this 1, right? I need to process the next bit, which is 0. So how do I get rid of this 1 bit, the least significant bit? Well, we shift the number by 1. There's a bitwise shift operator. We're going to shift to the right by 1, and you'll see how this looks like now. So now we just have 1, 1, 1, 0. We got rid of the 1. Now we're going to perform the same exact thing. Process the least significant bit, which is 0, and everything with 1. And now you see, we have 0, 0, 0, 0, right? So ANDing with 1 just gives us that least significant bit. And since this result is 0, it's not 1, we don't add 1 to our result. In this case, the 0 bit doesn't count. Okay, so we're done with this. Now let's shift this number again. So we're left with 1, 1, 1. We're going to do the same thing. Process the least significant bit, AND it with AND it with 1, and we get 1. So update our result. The number of ones is now 2 that we saw. Now let's shift to the right by 1, and we're left with 1, 1. Now we process the least significant bit, we AND the number with 1, and we're left with 1. So update the result, add 1 to it, which is 3. We've seen 3 ones so far. Now shift it, so we're left to our last bit, which is 1, and AND it with 1. In this case, this is just going to be 1. Since the result is 1, add 1 to our global result. The number of ones is now 4. Now we shift the number to the right by 1, and we have no more number, right? We're at 0 now. And so the time complexity of this algorithm is actually constant. It's O of 32 because an integer has 32 bits, and the space complexity is O of 1. So you could call this constant time and constant space complexity. All right, so let's start out the algorithm. The number of ones that we have is equal to 0. This is going to be our result. And like we said, we only have to process the algorithm 32 times because there's 32 bits in an integer. So for I in range 32, we're going to say that if the number, so if n and 1 is equal to 1, right? If this is equal to 1, that means the least significant bit is 1. So num1s plus equal 1. Else, well, we don't change the result, right? We do nothing. But in any case, we need to shift the number to the right ones. So n is equal to n shifted by 1. And that is the algorithm, right? It's pretty easy once you understand how to represent this number in the binary format. So let's run this, verify it succeeds. And there we have it. Thank you so much for watching. If you're interested in the Blind 75 LeetCode solutions in animated format, be sure to subscribe and like the video down below. It means a lot. I'll see you in the next one.